Okay, now the other assumption is that there is no correlation between x's and errors. Okay, that is exu is equal to 0. exu is equal to 0. So see, in case of correlation, okay, so in case if correlation is present, then this would lead to a bias. Okay, I mean the estimator which you're going to get is going to be a biased estimator. Fine. So suppose you have the model which is y equals to beta 1 plus beta 2 xi plus u. Okay, now in case if this x and u they are correlated, then the estimator is going to be a biased estimator. Okay, then estimator is going to be a biased estimator. See, as long as x's are non-random, then everything is fine. Okay, so one thing is there, x's are non-random. Okay, they are fixed. Since they are fixed, they could be taken out of the expectation operator. Clear? And one of our assumption is that on an average your error terms are equal to 0. So this would be x into 0, and this would be ex. This would be 0. Okay, hence exu would be equal to 0. Clear? So everything is fine till the point your x's are non-random. Okay, there is no correlation also. Now some more explanation to this is that suppose your true model is your y is equal to beta 1 plus beta 2 x star plus u. Clear? Okay, this is your true model. Fine, but you have but you're able to observe x only, not x star. Okay, and you observe it with some error. Fine, and if you estimate using x and not with x star, okay, so there is some amount of correlation which is going on here. So if you estimate instead of x star, if you estimate it using x, okay, it will have, I mean, the correlation with the error. So beta is going to be biased. Okay, beta, I mean your beta hat is going to be biased estimator. And if this is going to be biased estimator, this depends upon how large this error term is. In case if this is going to be a small term, then there's nothing problem, there's no problem with that. But if this is a large term, okay, then this is a problem. Okay, so so there is no correlation between the error term and the x's, your independent x's. Okay, so see, in case if the error term and these independent x, okay, these are correlated, so you can't actually tell the change in y is happening because of the change in x, or is it happening because of change in u. Okay, so is it happening because of the error, or is it happening because of the independent x. Okay, you want it to be only because of x. Okay, so for example, in the earlier example which you have taken, that your income is dependent upon your education level, you have assumed that. Okay, so and you've said this, that income is dependent upon your education level. So, and of course your but education and the other, and there are host of other factors which you have not included in this. Okay, so income also depends upon other things also. Okay, apart from the education level, it depends upon the age also. You have not taken that. Since you have not taken that, that has gone all into the error term. Okay, so and your with age your education is also increasing. Okay, with age your education is also increasing. Okay, so are these correlated? Okay, since age is a part of the error term, so the estimate which you're going to get is going to be a biased estimate. Clear? So you're assuming this, that there is no correlation between x's and the errors. There is absolutely no correlation within the x's and the errors. Okay, thanks.